Hello everyone, welcome to the course Programming Best Practices. In this video tutorial, we'll learn about few programming practice techniques. Basically, this will come handy when you are designing your code first, before you writing. So let's jump into the first slide of it, which talks about the maintainability. And as you know that how the well that you design your code, it is good to maintain your code. And maintainability is another aspect which must be maintained very seriously throughout your whole product. If you are writing, if you are a single developer or a multiple developer, doesn't matter. But the ultimate end product, software product that you are building, that should be very well maintainable. That should be the one of the aspect that your client is looking for, because he is putting the money on you, or maybe your team, or maybe on your company to develop a product. In return, what he expects that it will be so well developed that there will be very low maintenance cost, and that is a good aspect of a software product, that if your software is low at maintenance. So the first one is the dry principle, which is do not repeat yourself. So what does it mean by do not repeat yourself? So what does it mean is that as the name applies, so if you are writing a program, or if you are designing a particular program, or you are solving a particular solution, so the end result should be, you should not be repeating yourself, which means that you should not write your code in a repetitive manner. And that is why that every piece of knowledge must have a single unambiguous authoritative representation within a system. Okay, and that is why you can use this do not repeat yourself principle by using modular approach. That is the reusability of, like, if you create small functions or procedures which does its particular job, you create the modules, and then you call these modules whenever they are needed. So in that way, you are not repeating yourself. You are actually breaking your code down into different modules. It may be small, big, or medium modules, but you are actually not repeating yourself. Okay, so that is a good aspect. And another one approach is object-oriented programming, which we sometimes refer as a OOP. In object-oriented programming approach also, that you follow the do not repeat yourself principle. But remember anything, there is no hard rule. It's all depends on the developer who is actually designing, how he is thinking. So if you think rational, if you think liberal, then you'll be and if you follow this dry principle, then you should ask yourself the question repeatedly, that are you repeating your code? You should keep yourself asking this question. If you see that you are repeating your code, maybe not in file 1 but in file 2, then you should change your approach to make your coding style non-repeatable. And another good approach of this is MVC. And I forgot to mention this MVC into this particular slide, but I like to speak a little bit on this. This is one of the technique that has been used for most web developers, application developers. What does it mean is model, view, controller. M for model, V for view, and C for controller. This is technique been used just to follow this dry principle. Okay, so for an example, like let's say you are building an website. For an example, let's say in PHP. If you don't know PHP, that also doesn't matter. Just here, I'll just brief about what we are trying to do here. So as you know that your web page has its own, header part, right? Correct. And then it will be there will be one, either a navigation part. So let me do like this. Let's say this is your web page. Okay, so this is your header part, and this is your navigation part, and this is your footer part. So this is your header, this is your navigation, and this is your footer, right? So and this is the page content for each, and this changes for each and every page, right? But your header, navigation and footer doesn't change. So what does it mean is, your header, if you write your header, whatever the code inside it, the HTML code, each and every page, that means you are repeating yourself. And similarly, if you write the code for your left sidebar, or the navigation bar, so you are repeating yourself. Similar to the case for the footer. Now, instead of writing the header or the sidebar or the footer code to each and every page, what you can do is, you can create one template which will be containing the code for header. You can create another template which will be containing the code for left sidebar, and another content for footer which will be containing the code for footer, right? And then you include that particular code to each and every page. So let's say this is your page 1. Okay, so page 1 will have this code and its main content, and then this code. Similarly, in your page 2, it will have this code as a common, this code as a common. This main page content will be different because that's a different page, and you will be writing this main page content for each and every page differently. That you have to do. There you cannot do anything over here. You cannot help anything, just to avoid dry. But here, putting this particular code to each and every page, you are actually avoiding the repeating nature of your designing. So, and think about this. One good example that I can give you of this good practices. For example, let's say you have 5. Let's say you have 5 menu bar over here. Okay, so you have 5 menu bar over here in your header section. Now later on you decide to get rid of one. You don't want the third one. So if you have put this header code into each and every page, then what would have happened is, you have to open each and every page, and there you have to change your code. But in this approach, you have to just change your header underscore template.php. This particular file, if you change this one, the change will be reflected automatically to all your files where this particular file is been included. Right? So this is one good example of the advantage of dry principle. Continuing to the next slide about the maintainability, the point that here it's trying to say is that keep scope of your variables as small as possible to avoid confusion and ensure maintainability. So just avoid declaring everything as a global variable. Only declare the variables which are required to be global. But try to design your code or try to write your code in such a way that you are keeping the scope of a variable as small as possible. Of course, you have to define a global variable, there is no doubt about it, but only define those variables which are needed to be global. Don't put everything as a global, okay? Or just to avoid some complexity in your program, you are putting into global. No, don't take that route. Okay, use variables and routines for one purpose only. This is just to say that when you are declaring a variable, just purpose of that variable, you should determine that at the beginning, and then you should not use that particular variable for different purpose. For an example, let's say if I declare a variable called x, and then x is equal to, let's say I'm getting an interest of, let's say, p into r into n divided by 100, and then again I am writing something like x is equal to c minus f by 5 into 32, something like that. There is no meaning of putting a value of x over here with a calculation and putting a value of x with a different calculation. So if you are using a variable x is a very not a good name, of course, right? So let's say your variable name is your total interest, v underscore total interest. So that variable name should be used for your interest calculation. And then v underscore temperature calculation, that particular variable should be used for your temperature calculation. Okay. So, and also this rule applies for your functions, that is routines or the modules. Okay, keep in mind what control flow constructs do. For instance, this is very, again, it's all about the programmer. Okay, I mean, there is no hard rule, but it's good to avoid this kind of code. Instead of this kind of code, write this kind of code. Here, see, this will do the same thing. There is no difference on the output of the program, but here, I am writing a else if part. Here it's only done by the else. So this is much more readable than this one. Moving into the next slide, next tip is that avoid deep nesting. Too many levels of nesting can make code harder to read and follow. So just take this example of two codes. It is doing the same thing, but there is one level of nesting here, then it goes to another level over here, then it goes to another level over here. So basically it is going to the third level of nesting over here. So it is doing the same thing by, if I write my code in a different way, so there is no deep level nesting over here, it's only one level nesting. So this and this. Okay, so this is a good approach. Instead of this, sometimes you cannot avoid deep nesting, but if you really are able to avoid deep nesting, do that, because avoiding deep nesting helps increasing the readability of your code and also maintainability of your code. Moving to the next slide. Okay, here what is trying to say is, do not assume the output formats. Functions should return values in original type. The caller should decide what to do, reformat, send to the standard output, etc. So, for an example, you are declaring a function which is returning an integer value, which is basically calculating the simple interest and returning the simple interest. Okay, so normally the simple interest, the data type, return type will be kind of float or double, whatever it is. So do not assume that that whoever is going to use this particular function, he is going to use that as a number or integer value or a character value. No, because so whatever the calculation that you are going to get, that result is float. So do not mix and match with different data types. Return what is intended to do, leave it for the user. Now user get it as a float value and let him decide what he wants to do, right? Next point is, try to keep return point from a function as the last statement in the function. What is meant by, we'll be explaining through a different examples. So in this example, again, this and this are doing the same thing. Okay, this and this are doing the same thing, but here you see that this particular function get marks grade, this is actually returning a grade based on your input parameter marks, and it is returning return A if it is greater than or equal to 70, it is returning B, it is between 50 and 70, and if it returning C if it is 30 and 50, between 30 and 50, and at the end it is returning F, that is failed. So A, B, C and F are returned, but you see here multiple return statement has been used. This is 1, 2, 3 and 4. This is not a good approach. You should avoid writing your code like this when you are using return statement multiple times in a function. Okay, so instead of writing the code, it's a good approach that that you define a variable with return grade and initialize with F, and basically when it is greater than 70, then you initialize the variable return grade as A, or when this is the case then B, when this is the case then C, and then you finally use only one return statement, that is you are returning the return grade. So here this kind of technique is much more useful than this one. Instead of writing multiple return, use only one return statement. Try to do that. Sometimes yes, sometimes I understand that sometimes you have to write multiple return statement sometimes, but most of the cases, 90% of the cases, you can avoid writing multiple return statement and put only one return statement into your function. Moving into the next slide. So Here in this particular point, what it's trying to say is similar to return statement, use break, continue, go to, exit wisely. So why? Because break, continue, go to, exit, these are the statements that changes the flow of your program from one point to another point. Basically it jumps from one point to another point abruptly, and that is why it doesn't help in readability and maintainability of your program. So use at a minimal point. If you can manage your program, writing your code without them, do it. Okay, now this is about the error messages or failure, that you recover from your failure gracefully. Robust programs should report an error message and optimally attempt to continue. This is one good technique. Third point is provide useful error message. This is very important. Okay, sometimes you do not show the proper error message to the user, which is not correct. Whoever is using your software, he should get proper error message, and proper error message also interacts the user with the software. It enhances the interaction between them. So a good practice is you can whatever the user friendly message is, you can put it to the user, but whatever the technical error message, that you can put into some log files or something somewhere else. Okay, so that can help you as being a technical person, being a developer. You can diagnose that particular error message and see what that particular error message is about. But user should see a user friendly error message. It's not about the technical error message. Okay, now use constant literals instead of numeric or character literals. So just an example, if you write a code something like that, you see over here literals like I is less than is equal to 7 that is being used. So instead of if you are writing a code which is basically going for a week calculation or something like that, so basically you define a constant with days in week 7, and then I is less than is equal to days in week. So if you are trying to put what you are trying to put here is a meaningful name on your constant instead of the literal 7. So now we'll be discussing about the conclusion and goals, what we have learned from this course. So the first point is make your code highly readable. That should be the aim and the goals, right? And second is make your code highly maintainable. We have discussed about various techniques, tips, how you can design and write your code to make it more maintainable and very easier to maintainable. Third point is make your code modular and follow drive principle. We have discussed about the advantages of drive principle, and believe me, that really works. That works like a charm. And do code review with peers. This is a good practice, that once you write a code, you give the code to your peers and take their feedback, okay, and also let them look into it, that whether you are actually following the standard of the team or the client or the project. Programming is not an exact science, but the more you practice, the more you develop skills. That is the end point that I wanted to make. That it's all about practice, and practice. The more you practice, the more you adopt the skill, and the better the programmer you become each and every day. Okay, thank you for watching this video. If you have any comment or any suggestion, just let me know. Just put a comment on this web page. We have a website also, www.MyOnlineEdu.com, where we provide many programming courses online. So just take a look. If you are interested, let me know. Thank you very much for watching. Thank you.